Okay, we had a little video malfunction, but we're just going to pick up right where we left off. This is still 11.2, surface areas of prisms and cylinders, and we're working on quick check 1. I've already drawn the net for it. I just need to fill in my information. So let me go ahead and draw this dashed line right here down through the middle of my triangle. First, I need to make it a dashed line. That's pretty close. Okay, and then I'm going to label what I know. So what I know is these two sides of my triangle are 5 centimeters each. I'm going to label it down here as well. And I know that the bottom of my triangle is 6 centimeters. I also know that the edges of my lateral faces, all the sides of my rectangles, are 12 centimeters. 12, 12, 12, and 12. And with that information, I should be able to find the surface area of my triangular prism. Now remember that surface area is lateral area plus 2 times the area of the bases. Since we have 2 bases, if we find the area of one and multiply it times 2, then we end up with the 2 times the area of the bases. So I'll start by finding my lateral area, and maybe we'll just plug it into this formula. Surface area equals lateral area. Now let's see, if we're to find the area of a rectangle, I know that the area is length times width. And for this rectangle, I have area equals, okay, well let's see, if this side's 5, then I know also this side of my rectangle is 5 centimeters. So I just have 5 times 12. And I end up with the area is 60 centimeters squared. This rectangle is the same as this rectangle here. This is also 5 centimeters. This is also 12 centimeters. So the area of this rectangle is also 60 centimeters squared. This middle rectangle is a little different. It looks different, and it is. It's bigger. It has a longer width or a wider width. Again, the area is the length times the width. The length is still 12 centimeters. The width is 6 centimeters, and 12 times 6, I end up with 72 centimeters squared. So my lateral area would just be the sum of the areas of all my lateral faces. So I'll just say 60 plus 60 is 120. 120 plus 72, that's 192 centimeters squared. Plus 2 times the area of my base. So 2 times, now in here I'm going to put the area of my base. Well, I need to find the area of my base first. And my base is in the shape of a triangle. Okay, if I need to find the area of a triangle, let me think of some formulas for the area of a triangle. We've learned several this year. The first one, the most basic one and the most common one that we use is area equals 1/2 base times height, or base times height divided by 2. In order to use this formula, we have to know a base, which is any of its sides. We know all of its sides. We also have to know the height, and height has to be perpendicular to the base. Well, they drew us this dashed perpendicular line. They didn't tell us the length of it. Could we find the length of the height? Most certainly we could. But let's move on and see if there's an easier formula to use. The next formula would be area equals 1/2 opossum times perimeter. Do I know the perimeter of my triangle? I sure do. Do I know the opossum? No, I have to find it. And in fact, we can't even use that formula since this isn't an equilateral triangle. This is only for regular polygons. So let's see, I know of one more formula, area equals 1/2 times side times sine of the angle that we can use. Now we know all the sides, so we're good on the B and the C, but we don't know the angle. I do know that this is an isosceles triangle, but that still doesn't tell me what my angles are, so I also can't use this formula. My only option then is to use area equals 1/2 base times height. And if I'm going to use that, I'm going to have to find this perpendicular height right here. Well, what I notice is we have a right triangle. And since it's isosceles, when I drew this, or when they drew this perpendicular dashed line, it made that right angle, and it also cut the base in half. So that means if this whole side of this isosceles triangle is 6, then this side over here would be 3 centimeters. So now I know 2 of the sides of my right triangle, and I need to find the third side, my height. And what can you use to find that? Well, Pythagorean theorem. A squared plus B squared equals C squared, where A and B are always my legs, and C is always my hypotenuse. So I know one of my legs, 3 squared plus, I'm trying to find my height, so I'll plug in an h squared, equals, I know my hypotenuse, 5 squared. 3 squared, 9, plus h squared equals 5 squared, 25. Get h squared alone, subtract 9 from both sides. H squared equals 16, and then finally square root both sides, so that you end up with h equals 4. Now I know my base, 6, and I know my height, 4, so I can find the area of my triangle, and I'm just going to plug that right in here. 1/2 times the base, which we said was 6, times the height, which we said was 4. Now some people may wonder, why didn't we use 5 as the base? Or could we use 5 as the base? But again, you have to remember that base and height always have to be perpendicular. In that case, we cannot use the 5 since we don't know the perpendicular height for 5. Now, maybe we could have found it, but this was the easiest way. So now I'm going to solve my formula here. Surface area equals 192 centimeters squared plus 2 times 1/2, those cancel, and 6 times 4 is 24 centimeters squared as well, so that surface area equals 216 centimeters squared. And there's my surface area. Moving along to example 2. Now they want us to find the surface area of a 10 centimeter high right prism with triangular bases having 18 centimeter edges. And they want us to round to the nearest whole number. Now in this case they didn't give you a picture, but I went ahead and drew it to save some time. So you know that when they don't give you a picture, you can always draw it. So if it's a 10 centimeter high right prism with triangular bases, when they tell you it's 10 centimeters high, they're telling you the altitude right here, 10 centimeters, because remember that's our height. So 10, 10, 10. And the triangular bases have 18 centimeter edges. So they told me that the bases were triangles, and that's why I drew the bases as triangles. And since they just told you that the edges were 18 centimeters, that tells me these are equilateral triangles. That means every single side is 18 centimeters. And that's going to be really helpful when we try to find the area of our base. So again, we're finding surface area, which means I'll start with my surface area formula. Surface area equals lateral area plus 2 times the area of the base. Remember that B stands for area of the base, and we multiply it times 2 since we have 2 bases. So surface area equals lateral area. That is the sum of the area of all the lateral faces. And in this case, what I notice is that I have 3 lateral faces that are all rectangles that are all exactly the same. 10 by 18, 10 by 18, and 10 by 18. So I have 3 times 10 times 18 will give me the area of my lateral faces, plus 2 times the area of the base. Now again, we have to find the area of this triangle. So here we go with our formulas. Area equals half base times height. Area equals 1/2 apothem times perimeter. Area equals 1/2 side times sine of the angle. These are the 3 different formulas we could use for this triangle, and we can use 1/2 AP since it is an equilateral and thus equiangular and thus a regular polygon. So let's look at the 3 of these. First, we have area equals half base times height. We know all the bases because a base is just a side. So we have 3 sides, and we know all of them. We know the base. What we don't know is the height. Now, we could find it like we did on that very last problem that we did. We could draw that perpendicular height, and we could find it using Pythagorean theorem. That's fine. You may use that formula if you would like. Area equals half AP. Again, we know the perimeter. We don't know the apothem, but we could find it. So you could use that formula as well. Finally, we get to area equals half side times side. Well, we know all the sides, so we have that covered, times sine A. We don't have any angles here, but I think we could find them. Since it's an equilateral triangle, we know it's also equiangular. And since it's equiangular, we know that all the angles have to equal 60 degrees. So we know all the sides, and we know all the angles. Therefore, I think this formula is the best choice since you don't have to find anything besides the angles, which just took us no time at all. So we have 1/2 times side 18 times side 18 times, let me expand this out a little bit, times sine of the angle, which is 60 degrees. And again, you could type all this into your calculator if you wanted, or you can take it step by step. It's up to you. But either way, you end up in the end with an answer of 821 centimeters squared. Just be careful that your calculator is in degree mode, since you are using sine. Okay, let's look at a quick check here. The bases are a little different. Now they're not triangles, but we know how to find the area of these bases. And the bases here are these octagons, we know, because these are the only two congruent parallel faces in this shape. So our bases are the octagons. And again, we're just going to use the formulas to find lateral area and surface area of the prism. So surface area is lateral area plus 2 times the base. They want us to find the lateral area individually, so I'll start by finding the lateral area, which again, you know, is just the sum of the areas of all the lateral faces. Well, since this is a regular hexagon, that means each side is 6, and also all of these altitudes are 12, and I know that I have 6 lateral faces that are surrounding this hexagon. So I have 6 times the area of each rectangle. Again, to find the area of a rectangle, you just do length times width, and I know the length and the width are 6 and 12. So I'll do 6 times 12. And that will give me the area of 6 times 12 gives me the area of each rectangle. And again, I'm multiplying it times 6 so that I can end up with the area of all my lateral faces added together, my lateral area. When you multiply that together, you get 432 meters squared. So there's our lateral area. Now we need to find the area of the two bases so that we can add that to our lateral area so that we can get our surface area. So our surface area is 432 meters squared plus 2 times, and now we have to find the area of the base. Now this shape is a regular hexagon. There's only one formula we can use to find the area of a regular hexagon, and that is area equals half times apothem times perimeter. Now we already know the perimeter. It's the number of sides times the length of the sides, so 6 times 6, since we have 6 sides. So the perimeter is 36, that's taken care of. What we don't know is the apothem. So I'm going to, let's see, you can pull out a hexagon if you'd like, or you could pull out a triangle to try and find the apothem if you'd like, either way. So I'll just start by drawing my hexagon, and then I'll draw my perpendicular apothem. Remember, the apothem goes from the center perpendicular to the opposite side. I need to also find, so I'll just also draw my radii so I know how to find my angle here. You know, this is a right angle. Since the whole side's 6, that means that's 3. And I have to do 360 divided by the number of sides, which gives me 60. Again, that's the angle from radii to radii. And then you take the 60 and divide it by 2, and you get 30. And that 30 is this angle right here, 30 degrees. Once you know that, you know enough information to find your apothem. And you can either use your rules for 30, 60, 90, or you can use sine, cosine, and tangent. So let's see, if I use, I'd have to use tangent because I have opposite over adjacent. So I could do tan 30 equals opposite, which is 3, over adjacent, A, times A on both sides. So I get A tan 30 equals 3, and then divide both sides by tan 30. And this you have to put in your calculator, and you end up with 3 divided by tan 30 gives you 5.2. Rounded, of course. So 5.2 is my apothem. Now that I know my apothem, I can plug all this in, plus 2 times 5, we're going to do 1/2 times the apothem, which is 5.2, times the perimeter, which we said earlier was 36. Remember that these cancel, and from there you can just put this into your calculator. 432 plus 5.2 times 36, and you should end up with about 619 meters squared. Okay, we're going to have to stop for now. We will continue this in the next video.